There is an animal that never went on tour, never won a prize, and spent her entire life on a farm in Scotland. She never left the country, she never made a single public appearance. And yet, when she was born, she made front page news in almost every country on Earth. Scientists were stunned. Governments scrambled to respond. The public had no idea what to think. And for a while, neither did anyone else. This is the story of the most famous animal in the world. And by the end of this video, you will understand exactly why she changed everything. As with my last story, the events are told using C1 level vocabulary. So, this is your chance to test your English and see how advanced words work in real life. Let's begin. To appreciate why this story matters, we need to return to a fundamental idea. Living things reproduce. Animals have offspring. A sheep gives birth to a lamb, and that lamb inherits a combination of genetic material from both its parents. It had always been this way, and for most of human history, there was no reason to imagine it could be any different. For centuries, scientists understood reproduction as a process that required two individuals. Two parents, two sets of DNA, one new life. The notion that you could take a single adult cell from a living animal and use it to generate a creature that was genetically identical to the original had never been demonstrated in a mammal. It had been theorized, debated, and largely dismissed as something far beyond the reach of existing technology. And then, in a quiet, clinical laboratory on the outskirts of Edinburgh, a small team of scientists began to take that idea seriously. The team worked at an institution called the Roslin Institute, and the project was led by an embryologist named Ian Wilmot. What is worth knowing about Wilmot is that he was not the kind of scientist who sought attention. He did not hold press conferences or make ambitious declarations. He was methodical, careful, and had spent the better part of his career working on questions relating to animal reproduction and genetic modification. The objective of the project was not, in fact, to create a global sensation. The original aim was considerably more practical. The team wanted to develop a reliable method for producing genetically modified animals that could be used in medical research. Animals engineered to carry human proteins and potentially contribute to the development of treatments for serious diseases. To achieve that, they needed to pioneer a technique that had never been successfully applied to a mammal. They needed to produce a viable clone. The method they attempted is known as somatic cell nuclear transfer. In straightforward terms, what it involved was this. The scientists would extract the nucleus from an adult body cell. That is the part of the cell in which all the genetic information is stored, and then inject it into an egg cell from which the original nucleus had already been removed. If the procedure worked, The egg would behave as though it had just been fertilized and begin to develop into an embryo. That was the theory at any rate. What tends to be absent from many accounts of this story is just how many times the process failed before it succeeded. The team carried out this procedure 277 times. Not 7, not 27, 277. The vast majority of attempts did not progress beyond the embryo stage. Some resulted in pregnancies that were lost, others produced offspring with severe abnormalities. Had the team not been rigorous in their documentation of each failure, the subsequent attempts would have had little foundation to build on. It was the kind of slow, unglamorous scientific work that rarely makes it into the news, but without which the breakthrough would not have been possible. And then, on the 277th attempt, something changed. A lamb was born. She was healthy. She was, to all visible appearances, entirely normal. And she was, genetically speaking, an exact replica of the adult sheep from whose cell she had been created. A 6-year-old Finn Dorset sheep had provided the donor cell, and the lamb that arrived was, in every biological sense, her clone. They named her Dolly. The team kept Dolly's existence confidential for several months, whilst they conducted further tests and verified their results. It was only once they were certain of what they had achieved that the findings were submitted to the journal Nature. When the announcement came in February 1997, the response was immediate and overwhelming. This was not simply a breakthrough in the sense that one more experiment had yielded a positive result. It was a landmark moment in the history of biology. One of those rare occasions when a single discovery forces scientists to reconsider assumptions that had previously seemed unshakable. What the Roslin team had demonstrated was that a fully differentiated adult cell, a cell that had long since become specialized tissue within a living body, could be reprogrammed to function as though it were at the very beginning of its development. The implication of that finding extended far beyond the specific question of whether one particular sheep could be cloned. Dolly appeared on the front pages of newspapers around the world. Ian Wilmot found himself giving interviews he had not anticipated, and within days, the conversation shifted decisively away from the science and towards something much more difficult to resolve. The public reaction was not one of uncomplicated admiration. A profound unease took hold almost as quickly as the news spread. And the ethical questions that followed were not ones that science alone could answer. If a sheep could be cloned from a single adult cell, what was to prevent the same being done with a human being? Who would have the authority to decide whether that was permissible? And if human cloning were ever to become a reality, what would that mean for our understanding of identity, of individuality, of what it means to be a person? These were not questions with obvious answers, and different voices from scientists, religious leaders, politicians, and philosophers offered very different responses. The controversy reached governments with remarkable speed. Within months of the announcement, legislation was being drawn up in countries across the world to restrict or prohibit human reproductive cloning. In the United Kingdom, the Human Reproductive Cloning Act was passed in 2001. Elsewhere, the response was equally swift. What made the debate particularly complex was the distinction that needed to be drawn between reproductive cloning, which would result in the birth of a new individual, and what came to be called therapeutic cloning, in which cloned embryos would be used not to produce a person, but to generate specialized cells that might one day be used to treat disease. Whether the morality of these two applications could reasonably be judged by the same standards was a question that generated considerable disagreement, and in many respects, it still does. Dolly herself lived a relatively ordinary life, which is either reassuring or slightly anticlimactic, depending on your expectations. She was kept at the Roslin Institute under careful observation, and she eventually produced her own offspring, 6 lambs in total, all conceived through entirely conventional means. She was, by all accounts, a content and well cared for animal. She developed arthritis in her hind legs at an unusually early age, and in 2003, when she was 6 years old, she was put to sleep after being diagnosed with a progressive lung disease. Whether her early deterioration was connected to the cloning process, perhaps because the cell used to create her had already accumulated years of cellular aging before she was born, or whether it was simply a matter of misfortune, remains a subject of genuine scientific debate. The average Finn Dorset sheep lives to around 11 or 12 years old. Dolly didn't reach that. Her preserved body is now on display at the National Museum of Scotland in Edinburgh, where she continues to draw visitors who are curious, it seems, to see the animal in person, even though she is no longer alive to notice them. It can be tempting to conclude that the promise of Dolly's creation was never quite fulfilled. Human reproductive cloning has not occurred, at least not in any publicly verified case, and the alarming visions of 1997, a world populated by deliberately replicated human beings, did not materialize. But the legacy of what was achieved at Roslin is not measured in clones. The techniques developed by Wilmot's team, the ability to extract genetic material from one cell and inject it into another in a way that fundamentally alters what that cell becomes, laid the groundwork for an entire field of subsequent research. The understanding of cellular reprogramming that emerged from Dolly's creation became one of the foundations on which stem cell science was built, and that research has since produced some of the most significant advances in our understanding of how diseases develop and how they might be treated. Whether therapeutic cloning will ultimately prove to be a viable path to the treatments it has long promised is a question that remains genuinely open. What is not in question is that Dolly's birth moved the boundary of what science is capable of, and moved it permanently. The morality of where science goes next with that knowledge is, if anything, a more pressing question now than it was in 1997. So there you have it, a sheep born in a Scottish lab whose life was, in many ways, unremarkable, left behind a legacy that the scientific community is still building on today. Now, this story contained a lot of advanced vocabulary, and I know that trying to absorb it all whilst following the story is not easy. So, I've put together a free PDF for you. It has the full list of every C1 word from this video, along with definitions and exercises to help you practice using them yourself. You can download it using the link in the description. It's completely free and it's the best way to make sure these words actually stick. If you enjoyed this video, please like and subscribe, and I'll see you next time.